Hi, welcome to our second video on volume. In the last video we looked at the volume of a cube or a cuboid. Now we are going to look at a prism. Okay, so recapping what we talked about prisms in class. A prism is a 3D shape that has two identical faces at either side, and the shape just continues through in a kind of uniform way. It doesn't change from one side to the other in any way. A rectangle or a cube is a form of a prism. Other prisms you might be used to seeing around you might be, for example, a Toblerone box. It has a triangle at either side and it stays the same all the way through, so that's a prism. So what are we going to do to work out the volume of this prism? Let's start off. I'm going to show you a few. So on this page I have put some examples of a different prism, or a set of different prisms, just to give you an idea of what we are talking about and some terminology. So we look up in the top left for the moment. We have this prism, and you see I have two red triangles, one at either side of the shape. So each red triangle is what we would call the face of the prism. And then there's a concept we talk about with prisms where we talk about the height of the shape. But the height of a prism is not like the vertical height, which we would expect by looking at it. The height is better defined as the distance between the two identical faces. So in this case, that distance there is the height of our prism. It's front to back from the two identical faces. Then we look at this other triangular prism where the faces are top and bottom. So the height in this case maybe makes a little bit more sense to you. It is going up and down the way. So think about it like when we talked about the height of a trapezium. Okay, in a trapezium the height was the distance between the two parallel sides. So in this case the height is the distance between the two identical faces. So here, this yellow faced shape here, that's a 1, 2, 3, 4, 5, so that's a pentagonal prism, because we name the prisms based on the shape on either side of it. There are our pentagonal faces in yellow, and the height is going to be the distance front to back here. Okay, and I just thought I'd show you a couple of other prisms. If you like, this house obviously has the what we call the gable end of the house, which is a shape made up of a triangle and a rectangle, and then it continues all the way through the house there to give us the height from one face to the next. Or if we're camping, we have our tent that has our triangular faces at either side. Okay, so on the next slide I am going to show you a triangular prism. I'm just going to make it nice and simple and straightforward, and we're going to talk about how we would find the volume of any prism. Okay, so here I have got a triangular prism with blue faces. Okay, think back for a little second and I'll just draw one very, very roughly. To a cuboid. In our cuboid, well, how did we go from the area of this rectangular face down here, that was the length times the breadth, and then to work out the volume of our cuboid we multiplied by the height. So we're going to use that in order to find our formula for the volume of a prism. In general terms, what I've done with this cuboid is I have found the area of this face, and I have then multiplied it by the distance through my rectangle, which in this case I'm just thinking of as a prism. So, in order to find the volume of any prism, so let's put V prism, and what we need to do is we need to find two different things. We need to find A, the area of a face, multiplied by H, by the height of the prism. Or we may just say V equals AH. Okay? And there's a couple of different ways that I could do this. Probably the most straightforward way is that we are going to work out the area separately and just do a separate bit of working to multiply it by the height. So let's use an example of this triangular prism. This looks to me very much like it is an isosceles triangle, so let's just say that for now. Let's just say that we have a triangular face, which I'm going to show at the back of the shape, as being 6 by 6 centimeters. So I would start off by finding the area of my face as being a half times the base times the height. So that would be a half times 6 times 6. And again, remember, we could do this in any order. We could do half times 6 for 3 times 6 would give us 18. Same if I use the other 6. Or I could do 6 times 6, 36, and half my answer. I'm still going to end up with 18 centimeters squared for the area of that face. This little bit that I'm scribbling in on red. I know that I've got two of those. So in order to find the volume of the shape, I have to think about the distance from one face to the other, what we call the height of the prism, which I'm denoting by that red line going back and forward. For example, let's just say that that's 10 centimeters. Okay, so V for the volume of my prism is going to be the area times the height. In this case, 18 times 10, or 180 centimeters cubed. And there's your answer. So just to recap, prism, a shape has two identical faces, one at either side. We are going to find the area of that face to start off with, and then we're going to multiply that by the distance between the two identical faces, which in this case we're calling height. Make sure not to get confused the height of the prism with, for example, what we have here. Okay, stop working. What we have here, the height of the triangle. Don't get those two mixed up. Don't do what, for example, some pupils might have found that area of 18 and then see H in a formula and think, oh, that's part of the triangle, and multiply it by 6. You'll end up getting the wrong answer right at the very end. If you're very, very careful with that, you should have no problems whatsoever though.